Hey guys, today I'm going to teach you how to solve equations with special cases. By the end of this lesson, you'll be able to solve equations where there's one solution, no solution, or infinitely many solutions. You'll find out what that means by the end of this video. Go ahead and get out your binder, turn to the math section, and get ready to take some notes. Let's get started with a review of what we already know. This is an equation because there's an equal sign. It's got two steps because there's two things happening to the variable. It's times 2 and then plus 1. So we're going to take 2 steps to solve it. It's linear, and that might be a new word, but it's linear because whenever I graph this, it would be a straight line. I also know it's linear because the exponent on my x is 1. So that's the way we know it's linear. So a linear equation is every equation we've looked at so far. And there's one solution. What I mean by that is when I solve this equation, I will end up with only one possible number that could go in for x. The only possible number that goes in for x is 5. That's the only number that works. No other numbers can go in for x, only 5. That means there's one solution. However, today we're going to look at some special cases where there's some equations where maybe something else can come in for x, or maybe nothing could go in for x. So let's take a second and let's look at these examples here. So in this box, it says each of the equations below have been left with blanks. These are like your variables. Fill in the blanks with a number that will make the equation true. The number you pick for the blank must be the same number in each blank for that problem. So for example, what that means is in like B, there's 2 blanks. It has to be the same number in each blank. In here, there's only 1 blank, so that just has to be one number. But like in B and C and D and E, there's 2 blanks. If there's 2 blanks, it has to be the same number. So let's go ahead and look at A. Let's see if we can solve for that missing number. What is the missing number that goes here to multiply by 2 to equal -10? So what number times 2 equals a -10? See if you can think about that by yourself for a second. Okay, you should have thought it has to be a negative number because a negative times a positive is a negative. And then 5 times 2 is 10. So your answer should be -5. That's an example of a one-step equation where there's only one solution. There's only one number that can go into that blank, and it's -5. However, let's look at B. What number times 5 equals another number times 5? Well, let's just start trying some numbers out. What if I put in a positive 1? 1 times 5 is 5, and 1 times 5 is 5. 5 equals 5, so 1 could go in the blank. Another number that could go in the blank is 2. 2 times 5 is 10, and 2 times 5 is 10. See if you can think of another number that goes in the blank. Okay, you should have thought of a number, and if you thought of any number, you were right, because you can put any number into the blank, and it would end up equaling each other. So you can put any numbers. There's an infinite amount of numbers you could put in to the blanks here. So you can write whatever example you want. I just wrote any real number. Let's look at C. 3 plus a number equals 5 plus a number. So let's see if we can think of a number we can put in. It has to be the same number for both of them to make this true. It has to be the exact same number. So for example, if I put a 1 here into the first box, I have to put a 1 into the second blank. So 3 plus 1 is 4, but 5 plus 1 is 6. So it can't be 1. Maybe I should go down 1. Let's go down and say 3 plus 0. So 3 plus 0 is 3, and 5 plus 0 is 5. So that's not going to work. Let's start to see if we can think of anything else. Let me try one more thing before I give this away. Let's do maybe a negative number. Maybe negatives will work. Let's try -1, and it has to be the same number. So let's do -1. 3 plus -1 is 2. 5 plus -1 is 4. So I'm not getting any closer by putting these numbers in. What this should tell you is that nothing will work here. There is no solution here. It doesn't matter what number I pick. This can never be true because this is 3 plus that number and 5 plus that number. That'll always give me something that's not equal. Let's look at D. So D says 12 plus a number and 12 plus that same number. So this should remind you of B. If I put in a 1 here, and it has to be the same number for both of them, I would get 13 equals 13. So 1 could work. Another number that could work is 5. 12 plus 5 is 17, and 12 plus 5 is 17. So this is just an exercise in realizing what kind of solutions does our problem have. This is another example where there's any real number could go in for the blank. Let's look at E. We're just thinking here, is there any number that can -2 equaling the same number plus 2? Is there any number? Most people try 0 when they start out trying a number. It's we can always try 0. 0 minus 2 is negative 2. 0 plus 2 is positive 2. Negative 2 and positive 2 do not equal each other. The only rule is that they have to be the same number. So these blanks have to be the same. So I could try a 1. 1 minus 2 is negative 1, and 1 plus 2 is 3, so that doesn't work. So if the rule is they have to be the same number in each blank, then there is no solution here. Nothing will work. This is an example of no solution, just like in C. You're probably starting to figure out that there's either going to be one solution, no solution, or all real numbers, any solution. Let's look at F, see if we can figure out which one this one's going to be. 15 plus a number equals 25. Is there a number that works here? 15 plus a number equals 25. You should realize that 15 plus 10 equals 25. So just like A, this is another example where there's one solution to the problem. No other number will work. If I put in any other number, it will not equal 25. So let's just summarize what we found from this little experiment. In problems A and F, only one number would work. Only one number could work in those problems. So those were an example of problems that only had one solution. However, in problems B and D, the blue problems, any number would work. We could put in any number and it would make the equation true. So a solution is just the answer to a problem. And there are many answers to the problem. There's an infinite amount of answers we could have put in. So any number would have worked for B and D. And then the last one, we have the green problems. C and E had examples of equations where there are no solutions. Nothing can go into the blanks because it has to be the same number for both of them. Nothing works. So there's three types of problems here. We're looking at examples of one solution, no solution, and then this last one, infinitely many solutions. So like we talked about in a one solution problem, those are all the problems that we've been looking at to this point. In this type of equation, only one number will work to make the equation true. So an example of this type of equation is like 3x plus 12 equals 21. This is an example of a one solution equation because only one number can go into x to make that true. In the next example, there's no solution, or the solution does not exist. Sometimes we call that a DNE. So DNE does not exist. In this type of equation, there is no solution. There is not a number that will make the equation true. So an example of this type of equation might look something like this. You could have a 5x plus 1 equals 5x plus 3. Let me follow my same rules for solving an equation where there's a variable on both sides. I'll pick a side for my numbers and pick a side for my variables. I'll say the left is the x side and the right's my number side. I draw a line on the equals, and then I want to move this 5x over here to the left side of the equation. So I'm going to take away the positive 5x. When I take away 5x from 5x, on both sides, I'm left with 0. The only thing that I'm left with on the left is the number 1, and the only thing I'm left with on the right is the number 3. Does a 1 equal a 3? No. Obviously, 1 and 3 are not the same number. This is an example of a solution that does not exist, DNE, or you could write no solution. We will look at more examples of equations with no solution later on with these examples. So let's go ahead and look at the last type of problem, one where there's all real numbers or infinitely many solutions. These are like the blue ones, where there's any real number that could work here. So in this type of equation, any number or all numbers will work to make the equation true. Here's an example. Right off the bat, you should be able to tell that this 8x minus 2 is the exact same thing as negative 2 plus 8x. It's just written differently. But just to prove it, I'm going to go ahead and solve this equation just like I would an equation where there's a variable on both sides. So I'll pick a side for my variables. I'll say the left is my x and the right is my numbers. I draw a line on the equals. I need to get all of my x's from the right side to the left side. So I'm going to get rid of a positive 8x. So I'm going to subtract 8x. So I have 8x minus 8x. If you notice, there is nothing left, no x's on either side. And what I'm left with is negative 2 on the left and a negative 2 on the right. A negative 2 does equal a negative 2. That means that I could have put anything in for x and this would have been true. So when you get to the end of your problem and it says like this number equals this number, that means that there's infinitely many solutions. I could have put in anything for x. You could put infinitely many solutions or all real numbers and you would have been correct. Take a second and talk about what we learned today. So real quick, we've already learned about one solution equations. In the type of equations that we've been looking at up to this point, there's only one number that will work to make the equation true. The only other two things that we've learned today are these two special cases. Sometimes you'll get equations where there's no solution, and other times you'll get equations where there's all real solutions or anything can go in for the x. So let's go ahead and look at some more examples and see if we can figure out what type of equations we have here. So when we look here, we'll just figure out what type of equation is it, and then we'll solve for the variable if we can. So let's look at number 1. I can tell by looking at this problem what kind of solution it's going to have. Can you tell? If you can't, what we're going to do is we're going to go ahead and just solve it like normal. So I'm going to just pick a side. My variables are going to go on one side. My numbers are going to go on the other. So I just pick the left side for my variables, the right side for my numbers. I'm going to draw my line on the equals, and I'm going to move all of my x's from the right to the left. So I'm going to get rid of a negative 5x by adding 5x's. So if you look here, I have a negative 5x and a positive 5x canceling out on both sides. I'm left with a positive 13 equals a positive 13. Since a 13 equals 13, that's true, there's nothing else I can do to the equation, I should realize that this is an example of an equation with infinitely many solutions. That means that I could have put anything in for x and it would be true. You can try it out. You can put in a 0 for x, you can put in a 1 for x, you can put in a 2. You can just type it in your calculator and it'll be true every time. So this is an example of an equation where there's infinitely many solutions. You can also write this as all real numbers. So infinitely many solutions, all real numbers, either way, that is the way you would answer this question. On number 2, we will solve this out and then decide how many solutions it has. I'm looking at a multi-step equation where there's a variable on both sides. So I'm going to start by drawing my line on the equals, and I'm going to start by seeing if there's anything I can do on each side. So if I just cover up the right side and just look at the left here, I notice there's a number on the outside of parentheses, which means I'm going to go ahead and distribute. So I'm going to distribute this 7 to each term on the inside. This is the distributive property. If you forgot how to do this, I would go back and look at the simplifying expressions video. So the first thing I do is 7 times 2 is 14x, because there's an x attached to it. And then this is a negative 1 or a plus negative 1, so 7 times negative 1 is a negative 7. I also want to check on the right side if there's anything I can simplify over here. So there is. Numbers go with numbers. So this 1 goes with this negative 8. They're already being combined. So all I do is 1 plus negative 8. 1 plus negative 8 is negative 7. So on this side, I have 14x plus negative 7. Then I bring down my equal sign. So I want to take a second. Now that I've simplified over here and simplified over here, I have 14x plus negative 7 equals 14x plus negative 7. If this is true, 14x plus negative 7 equals 14x plus negative 7. They're the same thing. Then this x must be the same thing as this x. And that could be anything. So they're all real numbers. This is another example where the solution is all real numbers. And just remember, you can also write that as infinitely many solutions. There's an infinite number of solutions you can put in for x. So x could be anything. Let's go ahead and look at number 3. So just like any multi-step equation, I always want to start by drawing a line on the equals. I want to change any minus to a plus negative because they're the same thing and it just helps me keep organized. So if you notice, I've changed any minus to a plus negative. That's the only thing that I did. And then I drew my line on the equals. And then I'm going to pick a side for my x's, pick a side for my numbers. So I'm going to say this can be the x side and this can be my number side. Doesn't matter which side you pick as long as you move all your x's to one side and all your numbers to the other side. Then I want to look on each side of the equation and see if there's anything I can do. So over here I see a number on the outside of parentheses. That means I can distribute. So I'm going to go ahead and use my distributive property. This 2 on the outside gets multiplied to each term on the inside. This is 2x, and then this is a negative 12 because it's a plus negative 12. 2 times negative 6 is a negative 12. So don't get confused if you didn't change your signs. Then I bring down a 13 plus. I should also realize that I have more like terms. 13 plus goes with negative 12. Numbers go with numbers. So 13 plus negative 12 is just 1. So I have a 2x plus 1 on my left side of the equation. On the right side, there's nothing I can simplify, nothing I can combine. So I have a 4x plus negative 7. So I've got you started here. So go ahead and pause the video. See if you can try the rest of this, and then press play when you're ready to check. Hopefully you just looked at this and you realized that the first thing you needed to do was to move this 2x off of the left side over to the right side. So you take away 2x's from the left. If you do it to the left, you have to do it to the right. So I'm left with 1 on the left side, and I have 2x plus negative 7 on the right. So now I'm going to get rid of this negative 7 because this is my x side. So I'm going to get rid of this negative 7 by adding 7. So I have 8 equals 2x. So what number times 2 equals 8? That's the same thing as dividing by 2. I'm going to end up with 4 equals x. That means that there is one solution to this equation. So after all that work, there was only one number that can go in for x, and it's 4. I'm going to go ahead and stop showing you examples here. What I want you to do is pause the video, do all 3 of these by yourself. I'm going to put the answers up, so whenever you press play, the answers will be here. So go ahead and pause the video now. Okay, and then you should have just paused the video, so now I'm going to show you the answers. You should have found that you had 3 more examples of special cases. No solution, all real numbers, and no solution. If you had trouble with any of those or you didn't get those answers, please message me, call me, reach out to me in class so we can figure it out. But if you got all 3 of those right, give yourself a pat on the back. All right, guys, that's it. If you made it to the end of this video, please put your hero in the comments. Today we learned about equations where there are special cases. So now you should be able to solve equations where there's one solution, no solution, or infinitely many solutions. So go ahead and go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.